Hi, I'm JD, and what we're going to be doing today is find the probability of selecting two cards from your standardized 52 card deck. The first scenario is you want to find the probability of two aces with replacement, and then the second scenario is getting two aces. Again, you're selecting two cards without replacement, meaning that you get the card, right, and you hold on to it. Where with replacement is where you put the card back into the deck. So if you would, pause the video and see if you can try this one on your own. Alright, this is an and situation. You have two choices, right? And you want to get two aces. So, and also, since it's an and situation, you want to see if there's independence or dependence. Independence would mean that the events don't affect each other, where dependence does affect each other. So when you look at with replacement, those two choices, you have your first choice and your second choice, do they affect one another? And the answer is no, because you're putting the card, the ace, back into the deck. So they're independent. When they're independent, probability of, I don't know, first card, so F, and second card, you simply just multiply those two probabilities together. And this is letter A. Alright, so the probability of the first card, or getting aces, would be 4 out of 52. Times, you put the ace back in, that's going to be 4 out of 52 again, right? Because there's 4 aces in the deck out of a possible 52 cards. And then we're going to do a little decimal thing. So 4 times 4 is 16, and then you have 52 times 52. What I'm doing is I'm simply just typing in the calculator 16 over, and I put parentheses around the denominator, which is 52 times 52, and I get approximately, again, 3 decimal places, 0.06. Now your second situation, you have the probability of first card and the second card. This is going to be slightly different because this is without replacement. So once you have your little deck, right? You get an ace out. Let's see if I can find an ace real quick. Eee. Yes. You find an ace, so you take that out. How many aces are now in the deck? 3. And what's the total number of cards in the deck if there's 52? Taking one out, it's 51. So the probability of the first card is going to be the same, right? That scenario is not changing. That's not going to change it. What occurs is F has already happened. So they're actually dependent. So you have probability of F, and the probability of S selecting the second card, given that F has already happened. This would be conditional probability. The line stands for given that, meaning that F has already occurred. So the probabilities change. This still stays the same, so it's 4 over 52. Now how many aces, after I take an ace out, how many aces are left? Yeah, 3. How many total cards are left? 51. Alright, so you take your handy dandy calculator and just multiply these out. If you're doing straight across and you're not going to solve it right away, what you can do is put the numerator 4 times 3 in parentheses and then put 52 times 51 inside parentheses, but of course divide them. So parentheses 4 times 3 close parentheses open divided by open parentheses 52 times 51 close parentheses, and I get approximately, again 3 decimal places, 0.05. It's 4-5, so you take the 5 and you're going to round up, and so the third decimal place would round up to a positive 5. And that should make sense, right? If you're selecting 2 cards and there's replacement involved, about selecting aces or whatever card, it should be higher, right? Without replacement, this is leaving, and so it's going to be slightly lower. So, and that's it.